Where would we be without physics? It's the fundamental science when it comes to matter and energy, and we refer back to its laws for everything there ever is, was, or will be. When you think about it then, it's a little disconcerting to even consider that our understanding of physics also isn't infallible or complete. No matter how much we may think we don't know it all. Not by a long shot. And in various key fields, that's the reality that scientists are constantly grappling with. This is Unveiled, and today we're answering the extraordinary question, what if physics is wrong?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
In this video, we're taking a closer look at 4 significant ways in which it's increasingly believed, or even explicitly known, that our current physical models are wrong. These could be fresh and recent realizations, or long-standing overarching problems that science has wrestled with for years. But in both cases, the fact is that physics seemingly falls short, that we need to make amends or expand our horizons if we ever want to reach the next level of knowledge. First, we're diving into the darkest secrets of the universe for one of the most widespread unknowns in all of science: dark matter and dark energy. It's widespread in the sense that it's unknown according to pretty much everyone, but also in the sense that it is pretty much everywhere. Clearly, the universe is a vast and mysterious expanse, but the reality is more than just a little weird. The fact is that normal matter, that is, all that we can see and comprehend, only accounts for around 5% of the total mass energy content of the universe. The other 95% is made up of dark matter and dark energy. From the beginning, then, our physics is severely lacking, if not yet wrong, purely based on those numbers. Scientists have proposed the existence of dark matter and energy to explain the gravitational effects that can be observed acting upon galaxies and the accelerated expansion of the universe. But really, all this ever amounts to is a repeated refrain of, we just don't know what's happening. Imagine a cosmic detective story where researchers are hot on the trail of an invisible culprit. That culprit is dark matter and energy. Various experiments have been busily searching for smoking gun signs of our target in action, such as CERN's Large Hadron Collider particle accelerator. But after decades now of twisting and tweaking, the mystery persists, to the point where some physicists are now entertaining the idea that our understanding of gravity might be more generally incomplete. Modified Newtonian dynamics, or MOND, is one such theory, suggesting that we need to extend or modify general relativity to explain the universe without the need for dark matter and energy. The jury's out, but the science is currently creaking and could be about to collapse. Next, and the contemporary confusion certainly continues when we switch focus to quantum physics instead. Navigating the subatomic landscape on a journey toward quantum gravity is something that's demanded more and more research in recent years. However, are we any closer to uncovering the truth? Or have we simply moved nearer to confirming that our current scientific models just don't cut the mustard? To briefly recap, we know that the relationship between the very small, governed by quantum mechanics, and the vast expanse of space-time, ruled by general relativity, has long presented a profound challenge for physicists. The macro and micro laws just don't match up, which is why there's an ongoing search for a model that can unify our understanding of the universe, otherwise known as a theory of everything. If someone were to crack the science behind quantum gravity, then they'd go down in history as the one to unlock the cosmos once and for all. It's a shame then that we're arguably still no closer to finding that key than we were 10, 20, or even 50 years ago. String theory remains a promising avenue in the minds of some, repitching the universe so that the fundamental building blocks within it are tiny, vibrating strings rather than particles. But ultimately, even if string theory does work in theory, it's nowhere near proven. Recent experiments, especially those exploring the quantum properties of black holes, have provided fresh and tantalizing glimpses into the interface between quantum mechanics and gravity. But are these yet more false dawns? Is there something fundamental that we're missing? Is the inability to decipher a theory of everything further proof that physics is just wrong? Because, finally, even some of the seemingly immovable cornerstones of physics are now also being increasingly called into question. most notably the speed of light. Everyone knows that nothing moves faster than the speed of light in a vacuum. It's Physics 101, first page of the textbook. And yet, is it true? To some degree, possibly not. First, we know that universal expansion actually does take place at faster than the speed of light. Although, and as we found in a previous video, this is actually explainable without it being necessary to destroy all of our scientific know-how to make it work. So we'll just leave that one be for now. Second, we have the Alcubierre warp drive and other concepts like it, which again seemingly throw out all of the rules of light speed. In short, the Alcubierre drive is a hypothetical piece of future technology that would generate a warp bubble around it, inside of which the physical laws of light speed would never be broken, but outside of which it would be possible to move anyone or anything at speeds infinitely faster than light. If you wanted to jet across the universe in seconds and you had an Alcubierre drive fixed to your vehicle or person, then it would ultimately be a cosmic dawdle. And here again, the physics does check out without any major revisions needed. It's just that the drive would seemingly require some as yet unknown and possibly impossible materials to work. For faster than light speed that would require a new understanding of physics, however, we again head into the quantum realm. Here, there are now countless experiments ongoing and aiming to, among other things, teleport matter and information. At the heart of much of the research is a little thing called quantum entanglement. If you haven't already heard of it, then you're sure to become more and more familiar with it over the coming years. In short, it's a phenomenon in which pairs of subatomic particles appear to be intrinsically linked to the point that they could be used to deduce information channeled between them, even if they were to be positioned infinite distances apart. This is a potential game changer not just in science, but in the human experience, because it could ultimately provide scientific proof of a universe and reality that's so much more connected than we currently picture it to be. For some, it could well be that by analyzing quantum entanglement, we do finally develop a theory of everything. In this case, it's not as though our current physics is wrong, it's just that it's severely underdeveloped, and therefore our universe is inevitably underappreciated. And in truth, perhaps that's a better way to frame the challenges that lay ahead. No scientist would ever claim to have completed it when it comes to understanding everything. That's just not possible. And of course, we've seen throughout history how the general knowledge of our species can take and has taken monumental pivots and U-turns in the quest for understanding. We once thought the Earth was at the center of the cosmos. We once believed that the stars were gods. Will we one day look back on the present day and marvel at how we once pictured the atom? Or at how we were once wholly unaware of myriad subatomic pathways? For now, the prospect of dark matter, dark energy, quantum gravity, faster than light travel, and quantum entanglement all force us to continually rethink what we know, to forever shift the baseline of our shared global intelligence. If physics isn't exactly wrong, then it is always changing, and that's what makes it all so interesting. It's bizarre to think, but the fact is that whenever you look at anything, you're never actually seeing what's really there. We humans understand our everyday realities at the macro level, from teaspoons to train stations, from a speck of dust to a towering mountain. We know that there are smaller forces at play, but we can't actually comprehend them. More than that, though, in some cases, traditional science can't even properly explain them. This is Unveiled, and today we're answering the extraordinary question, what exactly is quantum entanglement?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
In simplest terms, a quantum is the smallest possible unit of whatever it is you're measuring. Therefore, in physics, quantum particles are the smallest of the small. First, we have atoms. Then we move into the subatomic realm with protons, neutrons, and electrons. And then we enter the lowest planes of quantum reality, an even smaller state, filled with quarks and leptons, and all of the other most fundamental pieces of existence. Quantum light is light at the photon level. Quantum matter is matter at the same, inimitably tiny base point. From the subatomic downwards, however, the laws of physics bend and break. Thanks to modern technology, scientists can view and measure what happens to some quantum particles. But what they've found seemingly makes very little sense. Quantum entanglement is the primary case in point. In short, it refers to how certain quantum particles can become bound or entangled with one another. This means that when a change happens and is observed in one of them, it's mirrored in its pair. For example, if one quantum particle spins top to bottom, the other spins bottom to top. What's especially strange, however, is that the distance between these particles for this link to happen seemingly doesn't matter, and also that the effect is apparently instantaneous, again irrespective of the distance between the two. The interest surrounding quantum entanglement dates back to the days of Albert Einstein, who famously referred to it as, quote, spooky action at a distance. According to Einstein's then emerging theories on the universe, it's impossible for information to travel faster than light. But quantum entanglement seemingly makes precisely that possible. We know that entangled particles could be split by hundreds of thousands of light years or more, but the instant connection would remain. To some degree, then, it might be said that information is still passed between them. A change to or observation of one would affect the other, and so it would appear that that information will have traveled beyond light speed, thanks to the entanglement. Today, there is still some debate as to whether this is really what's happening, though. For example, some theorize that actually entangled particles are preset and therefore unaffected by whatever happens to the other in its pair. According to this interpretation, information never really travels anywhere. It's more like it's just revealed to us. But that said, there are increasing numbers of experiments and technologies aiming to take advantage of the core principles at play. Perhaps the most eye-catching experiment of recent times came in December 2021 with the so-called quantum tardigrade. A multi-authored and international study was placed up for peer review, claiming to have achieved the first-ever quantum-entangled animal. Tardigrades are well known to anyone with even a passing interest in experimental science. These microscopic creatures are truly incredible and immensely durable. Tardigrades are known to have withstood and survived extreme temperatures and pressures, as well as some of the most challenging environments we know of, including the inner bellies of volcanoes and the otherwise lifeless void of the vacuum of space. In brief, it appears that tardigrades are capable of just shutting down their biologies to essentially ride out whatever existential problems come their way. But the team behind this latest study wanted to go one step further. They wanted to know how tardigrades would cope when even their subatomic makeup was put to the test. In the experiment, 3 tardigrades were frozen down to just above absolute zero, pushing them into their ultra-preservative state from the beginning. Next, however, those frozen tardigrades were positioned between a quantum circuit, generating quantum bits, or qubits. One of those qubits came into contact with and was affected by the tardigrades, before becoming entangled with another separate qubit as well. Over the course of the next 17 days, the team then measured and recorded how changes in one qubit triggered changes in the other, and the tardigrades too. Something of a 3-point entanglement had been created, with the relatively complex and multicellular tardigrades at its heart. At the end of the 17 days, the tardigrades were gradually warmed up and awoken, and while 2 died, 1 survived, leading the experimenters to claim it as the first ever quantum-entangled animal. The study was met with some criticism, however, with many onlookers arguing that the tardigrades had never been truly entangled, that just their close proximity to quantum processes wasn't enough to properly incorporate them into those processes. What's your verdict here? Did that one tardigrade truly go quantum? And had it really become entangled with the qubits running around and through it? The jury's out, but the debate continues to rumble on with some especially heady, hypothetical implications. For one, what would or could happen if a similar experiment was ever scaled up? What if human beings were to become quantum entangled in a similar way? Or even, are we already entangled together? We just don't know about it yet. For example, in 2017, the outline for a potentially pioneering study was published, investigating the possible links between human consciousness and the quantum realm. Fronted by the theoretical physicist Lucian Hardy, the idea borrowed from previous experiments looking into quantum entanglement, but further asked, what would happen if human beings were at the center, pulling the strings? Could human beings decide how entangled particles behave without any other input necessary? Elsewhere, similar proposals have led to various other lines of inquiry. For instance, could our thoughts alone trigger changes in entangled particles? And if so, would that mean that we really were capable of ESP-style powers of the mind? Meanwhile, there have also been tentative suggestions made toward using quantum entanglement to explain some other human connections, including love. Science already knows that there is a whole lot of literal chemistry involved in the emergence of love, but strip it even further back, and could our feelings for another person simply be the result of the subatomic binds between us? Perhaps it's not quite so romantic as some of the other explanations for our emotions, but it is still true that underneath it all, we are only atoms. Again, what's your verdict here? Could quantum mechanics really explain such seemingly unknowable topics as the human mind? Or is that just one quantum leap too far? Can even our highest emotions be boiled down into base connections of the subatomic sort? Let us know your thoughts in the comments. In either case, what has become increasingly clear over just the last few years is that the mysteries of quantum science could well prove to be vital to our growing understanding of reality as a whole. More often than not, when quantum physics makes the news, it's closely wrapped up in our ongoing development of quantum computers. And there's little doubt that there is huge potential in this field, with data and processing power like nothing we've ever seen before. But quantum entanglement is still about more than just the qubits of the future fueling faster devices. This is life, the universe, and everything at its most fundamental. This is the bottommost layer of all that we know and see and feel, and also all that we don't know as well. Really, it doesn't get much more exciting than that. It remains to be seen what the final destination will be. Quantum telepathy is one discussed possibility, although it still features almost solely as a science fiction concept only. Quantum mind control is perhaps another route we could head down if researchers can ever prove a kind of hyper-physical link between our thoughts and consciousness. In general, quantum communication could well bridge between here and literally anywhere else in the universe. In all likelihood, then, we're on the brink of another golden age of discovery, because that's what quantum entanglement really is.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.